In this video, we're going to discuss how to find the area between curves. So it's kind of like a motivating thing of how we would do the process. All right, how would you find the area of this shaded region? The shaded region is a really odd shape. It's a rectangle with a triangle missing. So how would you find that area? There's no formula for finding the area of a rectangle with a triangle missing. But what we could do is find the entire area of the rectangle. All right, find this whole area of the rectangle. We know that formula. It's going to give me everything in here. The area of the rectangle is 30 times 28. And 30 times 28 is 840. All right, so I know how that area, but that's more than I want. So how do I get rid of what I don't want? Well, I can find the area of just the triangle. And the area of just the triangle is 1/2 base times height. So 1/2 25 times 22. And that's going to be 25 times 22, 275. And then what do I do? If I take the green and I get rid of the red, then I'm just left with exactly what I want. So now I take the full rectangle, I subtract that triangle I don't want, and I get 565. So this is the basic idea of how we're going to find the area between curves. Is we're going to find more area than we want and subtract off what we don't want. All right, so let's look at an actual calculus example. How do we find the area of this shaded region? Well, the only area we know how to find is the area between a function and the x-axis. All right, so we can only do that for the purple line and the green line. So for the green line, I can find this area underneath the curve as this green shaded region here. For the purple line, I could find this area under the curve, and that goes up to the purple. All right, the blue is way more than I want because it has all this extra stuff down here. But if I subtract away the green part, then I'm only left with what I want inside this shaded region. All right, so this is the basic idea, is we're going to find two different areas, subtract off the part I don't want, and I'll get the actual area I do want, just like the triangle and the rectangle. All right, so here's what we're going to do. If we have f of x and g of x, we're going to find the area of f of x, that kind of top function. That's going to give me way more than I want. And I'm going to subtract off the area of g of x. That's the part I don't want. And I'm left with the area I do want. All right, so this is kind of the formula for finding the area between curves. But rather than memorizing a formula, just think intuitively about what you're doing. You're taking more area than you want and subtracting off the area that you don't want. All right, to find the area of the region bounded by y equals 2x, y equals x, and y equals 3. All right, so this one, it's always helpful to think about a picture. So y equals 2x is this line with a slope like that. Y equals x is a line with less slope. And x equals 3, let's just say it's here. All right, so that's going to create this area in here that I want to find. All right, so that area starts at the origin 0 and ends at x equals 3 because it's kind of telling me that's that place. The top function is that blue one, 2x. I'm going to subtract off the bottom function, x. And all of that is dx. All right, because we're going to do a derivative with respect to x. All right, here, before we do our antiderivative, we can actually simplify a bit. 2x minus x is just x. Then we do our antiderivative. Add 1 to the exponent, divide by the new exponent, move from 0 to 3. Plug in 3 first. Subtract when I plug in 0. Oops, not 0 there. 2. Right, that goes away. I just get 9 over 2. So 9/2 is the area between these regions. Right, you can see the basic idea of how we did it. We thought about what the graph was. We thought about the starting point and the ending point. Those give us our bounds. The top function was 2x. We subtract the bottom function, x. Right, so this is the process for finding the area between two curves. I wrote the area bounded by y equals 1 minus x squared and y equals 1 minus x. All right, so it's helpful to know kind of basic graphing stuff. When I see x squared, I automatically know my graph is going to be a parabola. When I see negative x squared, I know my graph is going to be an upside down parabola. So this graph is going to look like that. 1 minus x is a line because there's no exponent. Y-intercept's 1, slope is -1. So it's going to look like that. All right, I'm going to end up finding this region there. The only thing that makes this problem harder than the last problem is one, it might be a little bit harder to graph your equations, and two, they don't tell us where it starts and where it ends. All right. In my graph, it kind of looks like I could guesstimate what it was, but my graph is not perfect. So how do we know exactly where this starts and ends? Well, it starts where these two graphs hit each other, and it ends where they hit each other. Well, when do graphs hit each other? It's when they're equal. All right, so when these two graphs are equal, it's going to be kind of the edges of my area. I'm going to add x squared over, subtract 1, and I just get this. Solve this, I would factor out an x. And that gives me x equals 0 and x equals 1. So now my integral starts at 0. My area starts at 0 right here. It ends at 1. The top function is my upside down parabola. I subtract my bottom function like that. Here you could do some simplifying. Minus 1 plus x. All right, the 1s are going to cancel, minus x squared plus x. All right, now that I simplified that, I can now take a slightly easier antiderivative. It's going to be negative x cubed over 3 plus x squared over 2, evaluated from 0 to 1. I'm going to plug in 1 first. Plug in 0 second. Lucky, 0, everything goes away. And we get 1 over 6 as our final answer. All right, so in this one, you can see kind of the usefulness of kind of reviewing your Algebra 2 and pre-calc stuff, because knowing these graphs quickly is going to really help you kind of visualize what you're doing. Some of these questions are included in the calculator section, so you could just graph them to get a better idea, but not all of them. And then we figure out where we're starting, where we're ending. All right, think about what's on the top and what's on the bottom, and it's just evaluating an integral from there. All right, so here's one for you to try on your own. I found the area of the region bounded by y equals 3 minus x and y equals 6 plus 2x in the y-axis. All right, so go ahead and try that on your own. Draw a graph, see what it looks like. Try to evaluate your area. I'll show you the answer in 3, 2, 1. And the final answer I got was 3 over 2. All right, so this is the general graph. I know it ends at the y-axis because they're telling me that's where my area ends. So I have to set them equal to see where they start. It starts at negative 1. All right, the blue function is 6 plus 2x. That's on the top. The red function is 3 minus x. That's on the bottom. So top minus bottom. If you accidentally mix up top and bottom, the only thing that's going to happen is your final answer is going to be negative instead of positive. So just make it positive if you accidentally mess that up. But evaluate from there, antiderivatives, plugging values, simplifying, you get your answer. Right. As another quick reference, we're not going to do a whole example, but how would you find the area of this shaded region? We always want to do the top minus the bottom. We look at our thing, in some places green's on top, in some instances blue's on top. So just know that you can separate this up into 2 separate problems. You can find the area here, and it would be green minus blue. And you can find the area from here to there, and it would be blue minus green. So if you have a kind of complicated area that you're finding, you might have to separate up into multiple small problems. We won't actually be doing this a lot, but it's just something to be aware of. It's always the top minus the bottom. All right, so make sure if there's multiple different top functions, you might have to change your view a little bit. All right, so here's important things from this lesson. All right, to find the area between curves, you subtract the bottom function from the top function, so it's always top minus bottom. All right, you may need to solve an equation to find the starting and the end point. That's when your functions are going to hit each other. They're equal. All right, you may need to separate the area into multiple integral expressions. We didn't actually do an example of that. We just saw a picture. That might be something you have to do. And just knowing generally how to quickly graph a function is going to really help with problem solving and figure out where top's bottom, what's this area actually look like. All right, so these are all things you can practice in kind of your review of algebra and things like that.